unit of self-inductance is. So this time you need to find the value of self-inductance, the unit of self-inductance, but not the SI unit. You have been given different units and you need to pick the right unit of the self-inductance from these options. Now this question can be a little bit tricky. So let me do it for you. So self-inductance, in physics we denote this self-inductance by capital L. And if I need to find different units of self-inductance, I'll take the help of the formulas that I know from the chapter of electromagnetic inductions. Over there we discuss the concept of self-inductance as well as mutual inductance. So I'll take help of those formulas to get to the units that has been given to me, or I need to check which of the given is correct. So first unit, it takes into consideration the ohm and second. So ohm is somewhat related to resistance and second is somewhat related to time. So can you recall any formula which contains resistance and time as well as inductance? Any formula, कोई भी formula आपको ऐसा याद है जिसमें you have inductance, you have the resistance and you have the time. So I remember one such formula, that is tau, time constant of a LR circuit. Time constant of a LR circuit, it is given by tau, that is equal to L over R. Right? Now this time constant, it will have a unit of second. So this is going to have a unit of second and this is going to have a unit of ohm. So the unit of self-inductance from here, it becomes ohm second. Ohm second is the unit and it is given ohm second square. Ohm second square is given to you, but the unit is coming out to be equal to ohm second. So this one is wrong. Option 1 is wrong. Now let's head to the second. So it is dealing with Weber and Ampere. So do you remember any such formulas which includes the magnetic flux, current as well as the self-inductance? Any formula which links self-inductance, magnetic flux and current. So yes, I remember one such formula. Phi, the magnetic flux, it is given by L into I. Phi is given as Li. This is one of the formulas that we use or you use very intensively while dealing with the chapter of electromagnetic induction. So this phi, it will have a unit of Weber. L you need to find, this will have a unit of ampere. So one of the unit from here, it is coming out to be equal to Weber per unit ampere. So Weber per unit ampere, it is given as Weber per unit ampere square. So this one is also wrong. Now let's talk about the third one. So you have volt, second and ampere. So any formula that deal with EMF, current, time and the self-inductance. See, phi is given to you. The magnetic flux, it is written as Li. And we know that induced EMF, I'm writing only the magnitude part, it is d phi by dt. So it is written as L into di by dt. Induced EMF can be written as L into di by dt. So this will have a unit of volt, this will have a unit of ampere, and this will have a unit of second. So from here, the unit of L, it can be written as volt second per unit ampere. Volt second per unit ampere, you have been given volt second ampere. So this one is also wrong. This cannot be the correct answer. So if we have nullified 3 options, that means correct answer should be option 4. But obviously we have to derive this also. So dear students, if you have an inductor and if current I flows through the inductor, we know that energy stored, if it is a part of a circuit, it is given as half into L into I square, half Li square. This is also a very famous formula, half Li square. So this will have a unit of joule and this will have a unit of ampere square. So from here, one more unit of self-inductance is joule per ampere square. Let us get through the option. Yes, joule per ampere square is given to you. That means option 4 is the correct answer to this problem.